Okay, Bismillahirrahmanirrahim. In this video, today we will learn that how we can open existing data file. Like, let's suppose if the data file is in SPSS version, or it is in Excel, or it is in some other format. So how we can open that data file into the EViews, and we can use them for the purpose of analysis. So let's move towards the EViews first. Let's open EViews. Okay, let me close the old one and now open. Now, okay. Now click on the existing EViews file. Now I'll click on the desktop and then tell the views that where the file is actually located. So then go to the basic econometric folder, class 2, and if that is the views file, so you can click over here, the views file will be open. Now my file, let's suppose I want to open SPSS file. So that file is .sav. So now click on the SPSS file and income and expenses, and then click OK, and then click OK, and then click finish. You have the file now. We can use this file for our analysis purpose. Like, for example, we can see the income and consumption. We can select both and then click open as a group variable, and we can have a data over here. Like, we have income of the individual, we have consumption of the individual, and we can use this data for analysis purpose. Like, let's just click on this, and now go to the words now go towards the quick match option. Let's have a descriptive of the data. Go to the descriptive, and we will have now descriptive. That is how we can come to descriptive. And now we can have the correlation of these two variables, like the income, and go to the group statistics, quick group statistics, and then go to correlation. And why the variable is already been shown here? The reason is that I have selected these variables. That's why directly these variables are open. Like, now you just click on the group statistics and then click on the correlation. So now we will have, you just click on OK, we will get the correlation matrix. The income correlation with the income is 1, and the income correlation with the consumption is 0.94. Okay, let's suppose you have not selected the variable. Then in that case, you will be required to put the variables. Okay, let's again open the file. I have I have the history actually. All those files that I'm going to open will be available over here. Let's suppose I was actually having this file last time while doing the analysis. Now I'm not going to select these variables, and now go to quick, and then interested in correlation. Now there will be no variable. So if you initially selected the variable and then go to the quick option and then select any type of test, so by default the variable will be there. But if you have not selected the variable and you just directly go to the quick option and open any sort of test, then you will have to define the variable. Like, let's suppose my very first variable is consumption. So write down the spelling of consumption, and my second variable is income. So write down the income, or double click on here. Now click on this, we will get the results. Now let's suppose how to run a regression, analysis. Then go to the quick option, and then estimation equation, and click over here and define your dependent variable and independent variable. So my dependent variable is consumption, because I'm going to test that the individual consumption depend upon the individual income. Like, we have already presumed in the other videos that we are going to test this Keynes theory, in which Keynes says that the individual income is a function of consumption, and we have developed mathematical model that the individual consumption depends on the alpha, the intercept, and that of the beta coefficient and income. So this is actually the model that we are going to estimate it now. Okay, let's move towards estimate the model. Okay, first you will define consumption, then C, which is a constant, alpha, and then my income variable, that is independent variable, and then click OK. We will get the results of the regression. Now, like, we have a constant over here, that is minus 14 point, and its t value is here, and we have income, that is 0.95, and its t value is here, which is more than 2%, so it means it is significant. So there is a significant relationship between income and consumption. From this we can find out, and the relationship is positive because the beta is positive. So $1 change in the individual income will bring 0.95 cents change in the individual consumption. The rest of the portion of the income will goes to probably saving section. We can see here that the p value is less than 10%, 5%, or 1%. So it is also significant. R square is 88%. 88% changes in individual consumption pattern can be explained by changes in the individual income. That is the explanation of R square. And if we see the F statistics, so which is more than 4, that is 94. So it means that the overall model is statistically significant, and we can use the model for further forecasting. Like this is the forecast option. So we will discuss this section in the next video after discussing it in the class, but we can go for forecasting and we can do forecasting. Like these are the forecast on the basis of that model. Like we have y is the consumption and 2 standard deviation up consumption into standard deviation down consumption. Like these are the forecasted consumption. This is actually the actual line that we have estimated, that is beta, and these are the forecasted upper layer consumption, and these are the forecasted down layer consumption. We can have so many estimates, but we will discuss all these estimates with the passage of time. Now let's how to open uh, Excel file. This was actually a SPSS file. Now how to open Excel file? For example, let me close this file. I do not want to save this file. Okay, close it. No, I do not want to save it. Okay, now let's open Excel file. I'm interested to open an Excel file. Let's suppose I have a data, an Excel file, and I want to open Excel file. If that is 2007 onward Excel file, 2003 onward Excel file, then click on this option. But if that is 2009 to 2003 Excel file, then click on this option. Okay, move towards the where is the file. Just tell the software where the file is located. My file is located, that is CO pay in income. I'll click on this file. Any file I can open, but actually I'm interested in this file. Now click on next, and then next, and then finish. Now my data file is available over here. Now I do not want to have the same exercise after analysis every next time when I'm interested to open this file. So I can save this file as a EViews version. Like for example, go to the file and then click save as, and then define the place where you want to save the file. Let's suppose I'm going to save the file on desktop, and then click save. Okay, with double precision. Okay, now the file is saved. Let's check the file, either the file is available or not. Okay, let me close this file, and we can have reopen the file from there. Close EViews, and then go to the desktop. Where is the file? Where is the file? This is actually the file, CEO pay and income. Now I click on the file, double click on the file will be again reopen with the same variables. Now we have learned that how we can create a variable. Let's suppose if I'm going to add another variable into the list data, then click on the new object and define what is actually the variable. Let's this is actually the variable, the series variable, that, and its name is, let's suppose, the age of the CEO. Like we have a data of the CEO income and the CEO salary, percentage salary, and its return on equity, return on sale, and salary of the CEO and sale of the CEO. Let's suppose I'm also interested to include the age variable. Now how to create age variable? So click on the new object, then select series and then age, and then click OK. Okay, again click on the series and then age. Now click OK. Now we have the age variable. Now how to enter data in the age variable? So now again the cell is locked. So first of all, click over here and then click on the edit, and now enter the data. For example, the age of the CEO is 85, from whom the data was 45, the data was collected, and the second was 55, and the rest was 66, and so on. Now close this option and then click close. The data is available. Now how we can open this data? Like let's suppose this is the utility industry. Like this is a type of industry. This is the sale that has been done by the different CEOs. The data is available, and let's suppose this is the salary of the CEOs in different years. Like in this data, in this data we can test that how the CEO salary is going to improve the sale of the company. Increase in the salaries of the CEO, how that is going to improve the sale of the company. So we have different type of variables, like directly in dollar amount sale and dollar amount salary, and then we have computed return on sale and return on equity, and we have also computed percentage of salary and percentage of the sale. Now we can see these variables in group even. Like let's suppose I'm interested, I want to see these variable. Click on this variable and then press control button, and then click on this again, press control, click on this again, press control, click on this, and again press control and click on this, and then click open. Open is a group. Now you can see the different variable in one spreadsheet. So if you are interested to have each in the variable in spreadsheet, then you click an individual, you will have individual. But if you are interested to have a group variable in spreadsheet, so then select all those variable in which you are interested and then click them as a group. So now I have these variables in a group. Okay, now the next question is, like, I want to save this data. Now next time I want to save this data as in EViews version, so they click on save as and you can save the data. Now I want to do the descriptive analysis. I want to have a descriptive analysis. So now go to select those variable. Let's suppose I am interested to have the descriptive statistics of the sale, salaries, and the percentage of salaries, and the percentage of the return on equity, or let's suppose return on sale and return on equity. These are the variable in which I am interested to find out its descriptive statistics. I have selected the variable. Now go to the group and then descriptive and then comma. Now these variables are already there, and now click OK. We will have the descriptive results over here. Like you can see that the number of observations, the sum, the probability value, the normality test, kurtosis, deviation, minimum, maximum, all the data is available over here. Okay, let's suppose if I'm interested to find out the correlation between them. As you just see, these variables have been already been selected, and now I'm interested to find out the correlation. Once I have selected the variable, now will go to the correlation table, and I can find out the correlation. The variable are already been selected. Okay, click. We will have the correlation. The correlation between the sale and the sale is 1. The correlation between the sale and the salary is 0.11. The correlation between the sale and the percentage salary is 0.007. The correlation between the sale and that of return on equity is negative, and the correlation between the sale and that of return on sale is also negative. The correlation between the salary and the sale is 0.11, which is the same as this value, and the correlation between the salary and that of the salary is 1. Like the correlation of each variable with itself will always be equal to 1. Okay, now how we can run a regression analysis. So just go to the quick option and then click on the estimation equation. The data has already been selected, the variable has already been selected, but that has not been taken into consideration. We will define in this window about the dependent variable and the independent. For example, my dependent variable is the sale of the company, that's depend upon the constant C, and the salary of the CEO. If the salary of the CEO is going to increase, it is going to have, like, my hypothesis is like it is going to impact positively the sale of the company. Now click OK, we will get the results. Like if let's suppose we can see from here the constant value is 57.33, which shows that if there is no increase in the salary, still we will have this amount of sale, and it is significant. Its t value is more than 2, and its p value is less than 10%, 5% and 1%, so it is significant. Secondly, the salary is having a beta of 0.92, and its t value is 1.7, which is almost near to significant. though it is less than 2, but it is almost near to 2, so it is significant, which can be shown by the p-value. Like in the p-value table, we can see that it is more than, it is less than 10%. It is significant at 10%, but it is insignificant at 5%, because 5%, 8% is more than 5% and is more than 1%, but it is significant at 10%. So the R square is actually almost of 1.4%, and the F value is almost, which is again less than 4. So it is almost significant. If we see the p-value at 10%, it is significant, but at 5% and at 1%, it is insignificant, because the p-value is more than 1%, the p-value is more than 5%, but it is less than 10%. So at 10%, the overall model is statistically significant. At 10%, the beta is significant. Now if we can, we can interpret the results like, if we are going to increase $1 salary of the CEO, so it will improve our sale by 0.92. So it means that this is not a worthy contribution of the CEO. Even if we increase their salary, so we will have differential, less increase in sale than the amount that we are going to spend on the CEO in the form of, in terms of salary. So probably we should not go for the increase in salary of the CEO, just keeping in view that increasing the sale of the CEO.